Our good viewers, once again, welcome to our lesson. Wherever you are, keep safe, keep vigilant. Life is not simple. COVID is real. Make sure you and your neighbors are safe. We are Back Science Education Consultants, here with you to make sure that you continue learning from wherever you are. Today, we are going to study about liquid mixtures. In Ugandan education, this is senior 5. For these senior 5s, have where to write and have a calculator in your hands. We go ahead. Assume that you have liquid A and liquid B. You are at home. Get 2 liquids. Get 1 liquid and another in 2 bottles. Make sure they are not the same. Don't get water and you think you have 2 liquids. Let it be water, maybe something else. When you mix those 2 liquids, what is the expected resultant? What do you expect to form? There are 2 major chances. Either when you mix these 2 liquids, one of the chances is that there will be complete mixing. When there is complete mixing, you form a solution. Isn't it? Always you form a solution because they have completely mixed. You normally call it a uniform solution, but the solution itself, for it to be called a solution, it must be uniform anyway. So it is a solution, an indicator that it is always uniform. You know, there are other liquids which are funny, that they do not mix. Do not mix with each other. In other words, they there is formation of layers. Of layers. There is formation of layers. Meaning that we shall use this information to get 2 types of solutions. As we studied in lower levels, the first case is always called miscible liquids. Can you remember the name we give to the second form of liquids? Now, today we are going to concentrate much more on the first type of liquids. So we are going to majorly look at miscible liquids. Miscible liquids. What are miscible liquids? These are liquids. Like in this example, these are liquids that mix completely. They mix completely in any proportions. For example, if you have water and ethanol, this is a very common example given. If you have water and ethanol and you mix them together, regardless of the amount of water used, regardless of the amount of ethanol used, when mixed together, they completely mix. Even if you use drops, even if you use drams and liters. Now, what are we interested in this case? I want you to start thinking about the difference between the solution formed, the solution formed after mixing two liquids. In other words, the solution and pure liquid. We start thinking about the difference between those two. And in particular, I want us to concentrate on some differences. Can you consider the liquids you chose here? The liquids you chose. Consider your liquids again. A and B. Go back and get your liquids. Go back and get your liquids. And in this case, I want you to be keen and choose liquids that are miscible. Choose liquids that are miscible. These are miscible. Do not mix them. Do not mix them. First get A alone. First get A alone and B alone in your containers. And I want us to think about what happens when we boil these two liquids. If you have a metallic pan, you have a glass that is hard enough to withstand heat, you can heat them. You can heat them until when they boil. I want us to consider heating them. When you heat, what happens? The temperature will increase. And when the temperature increases always, a liquid, what happens to a liquid when the temperature increases? Definitely, there will be evaporation. There must be evaporation. When you boil, when you heat a liquid, it must evaporate. Why does it evaporate? That is simple science. The kinetic energy of the molecules increases, and so they break the intermolecular forces that are making them be liquid. They escape. They escape. That is simple physics that we shall not go into its details. What are we interested in? This vapor always can escape completely, but some of the vapor does not go. Even here, some of it may escape completely, but some of it does not go. It accumulates. In fact, at one point, some vapor starts going back, some vapor starts returning. It starts returning. It starts changing back into a liquid. Remember, we are considering the pure A, pure B. Now, there is a point that we call boiling. When does boiling take place? We used to say that boiling takes place. That boiling takes place when the vapor pressure of the liquid is equal to the atmospheric pressure. Please, we are assuming that this one, at least you know, that for boiling to take place, vapor pressure must be equal to atmospheric pressure. I want us to choose those two words. What is vapor pressure? The vapor that accumulates here reaches a point when it keeps on exerting a particular pressure on top of the liquid. the vapor changes back to the liquid, but the one which remains there, the one which remains on top, keeps on exerting a particular pressure on the top of the liquid. It accumulates. A point reaches when the number of molecules that are escaping from the liquid to vapor are equal to the number of molecules that are coming from vapor to the liquid. That's when we say that the vapor is in equilibrium. The vapor is in equilibrium. The vapor is in equilibrium with the liquid. The vapor that has been formed is returning into a liquid. But because you are heating, the liquid also must evaporate. A point reaches when they are in equilibrium. In the same way, a point reaches when the two are in equilibrium. The pressure, remember that the vapor is exerting on the surface, is the one we are calling vapor pressure. Is the one we are calling vapor pressure. Can we leave that at that? Consider mixing air with salt. Just go pick salt. Salt is not expensive. You can pick some little, mix with air. Make sure you mix very well. And you make sure that they mix completely. So, when you have finished mixing, label this one liquid air with salt. And you heat. If you can't heat, imagine what will happen if you heat. When you heat, you will realize that much as this is a solution, a salt solution, you will realize that when you trap the vapor and test it, it will taste as if there is no salt. You will find that the vapor only contains water. Why? It's because salt is not volatile. The salt cannot vaporize. It cannot vaporize. It cannot vaporize. Can we consider again mixing, adding B to A, add B to A, add B to A. Say that this is A mixed with B. This is what we have called a solution. A liquid solution. This liquid A mixed with liquid B. It is also a solution like this. You know, we have always thought about them differently, yet their properties are almost the same. The way salt affects liquid A is the same way liquid B will affect A, because they are both solutions. There are few differences, and these are the differences that we are aiming at. Can you heat this solution? What will happen? When you heat, remember here you heated A, it vaporized. You heated B, it vaporized. What happens when you mix them together? They will still vaporize. So the vapor will contain A and B. They will be mixed together in the vapor. That is the only difference between a solution made by dissolving a solid in a liquid and a solution made by dissolving two liquids. Let me hope you are not disappointed and you have found that your liquids you have chosen are immiscible. Now
there is something that we must understand in this case. For example, is water, and B is ethanol. Remember, water boils at 100. Ethanol boils at something like 78, 77 point something, close to 78. When you boil these two, which of them will be more in the vapor? No. This question is simple. Assume A boils at 100 degrees Celsius and B boils at 78 degrees Celsius. Which of the two liquids is more than the other in the vapor? Please, this is a good question which you should answer, and you give a reason. No, give a reason. A reason will confirm to you that you have understood or you have not. Huh? I beg that you answer this question. It is a simple question. Visit us on our emails and our WhatsApp numbers. Visit our YouTube channel. Subscribe. Keep following. Make sure you pass the question. Wait for the rest of the work in the next video.